Thank you. So, good morning, everyone. My name is Anita Carleton. As Jerome had indicated, I lead the Software Solutions Division at the Software Engineering Institute, and I'd really like to welcome all of you to the AADL user day. I was asking Jerome and I was asking Alex, I know this is the second event, the second AADL user day, but I wasn't sure quite when the first one was, and I was told that it was February and it was in Huntsville. So I think these are great locations to have these kinds of forums. So welcome to everyone. It's great to see such a large and broad community here interested in model-based engineering for embedded systems. We have an incredibly strong program planned with presentations from people from OSD, from DARPA, and the Future Vertical Lift program, as well as demonstrations from tool developers. And so for those who are also interested in digital engineering environment development and DevSecOps for real-time systems, I think that you will also find this event to be enormously helpful. You will learn about the technologies, the practices, the processes that I think can really ultimately enhance your capabilities. So let's get started. I'm just going to provide a brief introduction and then turn it over to our keynote presenter, Dr. Bonneau. Wow, it's really, I'm high up here. I never get to be this tall, so this is awesome. This is a great view. So the SEI is incredibly happy to host this event, and I'd like to just say a few words about the SEI. The SEI is DoD's FFRDC, Federally Funded Research and Development Center for Achieving Mission Impact Through Software. The SEI solves national defense strategy challenges and has focused research in software, cybersecurity, and artificial intelligence. We were established in 1984 and are at Carnegie Mellon, located at Carnegie Mellon University in Pittsburgh. We've got about 700 employees, and we're headquartered in Pittsburgh, have an office here in Arlington, and have some operating locations near key customer facilities in Boston, at Pax River, San Antonio, and LA. So the CMU SEI vision is a DoD able to gain and sustain advantage over adversaries through software. So that's really what all of our research and practice work is focused on, is how do we make software the strategic advantage for the Department of Defense. The SEI has been improving the practice of software engineering for more than 30 years. You may be familiar with some of our earlier work in software process and measurement, starting with the CMM and CMMI days, to our architecture work, our product lines work, software assurance and verification, and cybersecurity initiatives, and more recently, our focus on agile work, DevOps, and AI engineering. But what you'll also notice on here is a book on AADL. And we've been involved in AADL development since its beginning nearly 20 years ago or so. And later this morning, you're going to be hearing from Peter Filer, who's an SEI fellow, who's been really one of our key players in AADL development and standardization. And his book is on model-based engineering with AADL. So as you're going to hear all throughout the day, AADL is having great impact, and the SEI is incredibly committed to the transition of AADL into broad practice. So many of you here do know about AADL, but for the few that may not know, I think AADL has the potential to radically change the way software is developed. And so the phrase here, before you ever write a line of code, I mean, this is really key here. AADL allows you to design the entire system. You can see where the problems are going to occur, and then you can change the design of the system to eliminate those errors. Software problems, data issues, hardware problems, any of those kinds of things. But you have the opportunity then to design the system so those kinds of problems don't occur. You're not then building up the technical debt in software in terms of writing code and so on. So some of the photos that you see here are some of the places where AADL is being used. The Black Hawk helicopter, AADL provided early performance insight and risk reduction opportunities. The next photo is on the satellite system, validated architectures through proof-based techniques. And then the third one, some work with the FDA using AADL, applying the research to address software problems as a part of their infusion pump improvement initiative, which really was all about making these infusion pumps faster and more reliable. So if you know about what these pumps are, they deliver sort of the liquid medications and the nutrients to patients. So we're talking about life-critical kinds of applications and systems here. So I think Alex alluded to the problem space that we're talking about here. We're most concerned with when we talk about model-based engineering for embedded systems with respect to these critical kinds of systems. Systems whose failure is intolerable because it can cause mission failure, because there's unacceptable cost, or even human injury or death. So these are the kinds of applications where AADL is incredibly helpful. So as highlighted by the recent Defense Innovation Board study, major system developments like the F-35 and the Boeing 787 have demonstrated that there are major gaps in software system development processes requiring significant software rework to achieve integration. So AADL and ACVIP then enable early virtual integration and prototyping to discover and mitigate emergent issues even before physical integration. So as we think about some of the traditional methods and practices, as we think about the complexity of the systems that we're working on, those kinds of methods are no longer good enough for the critical systems that we need to build. So the SEI is trying to bring what we've learned through our research and prototyping of these capabilities so that we can actually field these innovations more quickly. So the phrase, and I'm sure others are going to show these kinds of diagrams, model, integrate, analyze, and then build. A totally different way to think about how we build our software. We just recently had the SEI research review last week, and Alex, if these words look familiar, they're from one of your charts, so I acknowledge that, but Alex, I thought, captured the benefits of AADL and ACVIP so very nicely, talking about decreasing fielding time by finding problems early risk reduction, using AADL and ACVIP to improve system security, and of course, decreasing overall and development costs. So over many years, the SEI's had an outstanding partnership with the U.S. Army through Alex Boydston and Dan Bailey, and certainly many others that we're working closely with. This group is the vanguard of applying AADL and ACVIP to the Army's future vertical lift challenges. And this work is the outcome of 20 years of research, both internally, supported by the SEI, and externally, funded by various DoD customers, with the U.S. Army being the prime champion. So I wanted to acknowledge this. In the latest issue of Army Magazine, I thought this was a great article on revolutionizing Army aviation, and it talks about all the different major systems and what the software, hardware, security issues are, and that, you know, there's got to be better ways of putting these kinds of complex systems together, and references the AADL work. So as we look ahead, the SCI is incredibly committed to advancing AADL, advancing it beyond even the 20-year commitment that we've made to AADL. Throughout the day, you're going to be hearing a lot more about the future of AADL and ACVIP, and I'd like to just highlight a couple of the things that you're going to be hearing about and what's important to SCI and what we're going to invest some of our research projects on. The first one here, engaging collaborators to use AADL tools and to provide sort of that real-world input. So we've got to know what's working, what isn't, and constantly feed that back into our research program. Linking ACVIP to digital engineering and exploring the ways to leverage these model-based techniques to improve DoD procurement practice. And then the third one, as we talked about at our recent research review, is how do we look at the impact of these emerging technologies? AI, DevOps, formal verifications of behavior, but how do we then integrate the emerging technologies into AADL and ACVIP? Okay,